A team of 10 dogs is pulling a dog sled at a constant velocity. What does constant velocity tell us about F net?
0.
It's 0. So let's make that statement right there so that we don't get ahead of ourselves. A constant velocity of 8.1 kilometers per hour over the frozen tundra. The dog sled has a total mass of 1,000 kilograms. Calculate the coefficient of kinetic friction, so that would be U mu K, between the dog sled and the snow if the dogs must exert a total force of 922 newtons to keep the dog sled traveling. Okay, lots of information going on here, so let's draw a free body diagram to kind of conceptualize everything. So here's our dog sled. We know we have F app is 922 newtons. We'll have our FF as well. We have our FG and our FN. And let's also write in, this is the direction. I'm just going to put D of M. What does that stand for? Direction of motion. So, just like with our kinetics unit, we have to break up these vectors into horizontal and vertical. Because, let's look at this. Our formula that we need is FF is equal to mu Fn. If we look at our free body diagram, this FF, look, it is horizontal.
So what are those big bars?
Pardon me?
Why is there big bars in
I still can't hear you.
Why is there big bars in the equation?
Big.
There's absolute values.
I still don't know what. Why? Oh, why is there bars? Because they're absolute values? In math, you have to put bars in absolute values? Okay, that's why. Thanks.
So,
It's just when you put it in your calculator.
so I have to put them bars in my calculator.
Okay, well, we'll do that in a bit. Now, in our Fn, look, it's vertical. So we need to break this information up into horizontal and vertical values. So that's really, really important. Okay, so the first thing we're going to do, let's deal with our vertical information. So, vertical F net. So F net, and put a Y underneath of it to remind you. This is really important that we make sure that we know that we're talking about vertical, which is Y, and horizontal, which is X. This was what a lot of you got mixed up in your projectile motion. So please make the effort to separate to vertical and horizontal X and Y. So F net Y is equal to Fn plus Fg.
How do you know that?
Because when I look at my vertical of my free body diagram, I have Fn and Fg. So I'm saying the overall force is combining these two together. This is going to be a positive and this is going to be a negative. Yeah.
So, why did you put the Y underneath the F?
Because this is all about my vertical values. On a graph, your vertical is Y and your horizontal is X.
I thought F-net was horizontal.
I feel you.
No, F net can be referred to horizontal or vertical. So when we did our gravity questions with the elevator, we had to go F net is equal to Ft plus Fg. Same here. So we can have F net horizontal and we have F net vertical. Good questions. And you find the formula by looking at your free body diagram, which is why it's really important to draw your free body diagram first. Okay? Does that clarify those questions? Good. Yeah, it's good to stop now and ask those. Okay. But is this dog sled moving up or down? No. So we can conclude that F net for its vertical is 0 because the dog sled's not falling and it's not going up at all. So there's no acceleration vertically, either up or down. Therefore, F net y is equal to 0.0 newtons. Therefore, then, we can say that Fg now is equal to Fn. So, let's find, we can't calculate Fn, but we can calculate Fg. And I want to find Fn because I need that for my formula. Okay, so overall I need to find Fn, but I can't calculate Fn with anything I'm given, but I can find Fg. So Fg is equal to mass times the acceleration due to gravity. So Fg is equal to 1,000 kilograms multiplied by negative 9.81 meters per second squared. So my Fg is going to equal 9,810 newtons. So I'm going to put that here, 9,810 newtons. So what must my Fn be then? It needs to be positive, so now it's positive 9,810 newtons. Okay, so does everyone have their vertical done? Now we need to find out our horizontal, because this is what we're actually trying to find as our answer, right? That's our overall question. But we still need to find this in order to put it all in. So again, we say F net is equal to, for horizontal, it's FF plus F app. What can we set our F net to in this question? It's 0 because it's constant velocity. F net of my x is equal to 0. This isn't always the case in every question that you set F net to 0. This is just the case in this type of question because it's at a constant velocity.
So when you
Of horizontal, yeah. Yeah. If it's not moving up or down for vertical, then this F net is 0 too. So if it only has horizontal motion, yeah. Okay. So then I can say FF then is equal to FF. Well, what did I know about FF? Was I told that in my question? I certainly was. FF is 922 newtons, so I can set FF is equal to negative 922 newtons. Okay, so now we can do our third step. So now we're actually concerned with our mu, and this is what we can find out now. So mu now is equal to FF divided by Fn. Now, you guys could correct me if I'm wrong, we don't need to worry about our negative values for our absolute, right?
Yeah.
That's right, okay. So, thank you. So because these are absolute values, we don't need to worry about our negatives and our positives. Is that right, math people? Okay, thank you. So, mu is equal to 922 newtons divided by 9,810 newtons. So don't need negative or positive because absolute. So mu is equal to 0.093985, etc. So let's put this to sig digs, which we have 2 sig digs. So 0.094, no units, no directions, nothing. If you wanted to, yeah, just 2 sig digs. If you wanted to, you could put this into scientific notation. 9.4 times 10 to the